Hi, my name is Chamarty. I'm the team leader for Model 28 or Class Team 28. Our project is about classifying real-world environments using machine learning models, from forests and mountains to streets and buildings. This helps autonomous robots understand where they are and how to move safely. We compared three models: Logistic Regression, a shallow MLP, and a deep convolutional neural network on the Intel Classification Dataset.
Hi, I'm Taylor from Model 28 or Class Team 28, and I worked on the MLP model for our project. Our MLP model is an atom-optimized two-layer model, so 4 layers total with a learning rate of 0.0001, which isn't shown here because this is just the model definition. For each layer, save for the output layer, we have a dense layer that uses ReLU activation, followed by a drop layer with a dropout rate of 0.1. The input layer uses 256 neurons, and this number decreases by half for each layer until the output layer. And our output layer uses softmax activation and has 6 output neurons for our 6 classes.
Hi, I'm Karen Liu, the CNN architect for our project. Our CNN model takes 150 by 150 color images and runs them through layers to find patterns, then predicts which of the 6 environment types the image belongs to.
My name is Jason, I was in charge of creating the multinomial logistic regression model. For the model, I used a softmax activation function for predicting the output for my model. And for optimization, I used grid search to find the optimal hyperparameter values of learning rate, regularization type, strength, momentum, batch size, and stochastic gradient descent for minimizing the cross-entropy loss function.
Now let's run the model. Once you clone our repo from GitHub, make sure you are in the project directory and cd Flask deploy directory. Once you are in the Flask deploy directory, run python app.py to run the Flask environment and the web page. This is the web page link. Put it on your intended browser and you can see the model running. Alright, now let's get to the demo.
I'm Thomas. I was the pre-processing lead for this project. Basically, I built the pre-processing pipeline after doing exploratory data analysis. So let's say we wanted to predict an image. Let's say we wanted to predict a mountain image. We could search Google, find an image of a mountain. Let's say pick this one. We can take, say, a screenshot of it or just save the image. And then you can take that screenshot and go back to the model, and then you can upload it and predict it using the models, and we'll see how it does.
Let's look at another example. Let's take an example of streets. Yeah, as you can see, this is definitely a street. Let's take a screenshot and then go to our classifier, recents, there you go, street, and predict. As you can see, all 3 of our models predicted street, which is amazing, with different confidence rates. Let's take another example, sea for instance. Let's choose this image, take a screenshot, and save it. Once we do that, let's add the file to our web application and predict. As you can see, CNN predicted sea with 40% confidence, while MLP and Logistic Regression had glaciers. This is because for sea and glaciers, the RGB values were pretty similar.
And then finally, let's say we want to have a forest image. So we can search a forest, and we can pick any old forest, take it in, take a screenshot, and then we can go upload that to the model. Yeah, so as you can see, all 3 models are quite good at predicting forest images, just because forest images are very distinct, both in terms of color and in terms of shape, which is why both the regression models, perception models, and the CNN did very well in predicting the forest images.
This project shows how machine learning can help robots recognize their environment. Thanks for watching. You can find our code on GitHub and read more in our project report.